glad to have everyone here. Scott and I are going to talk you through some of our current work that's happening both on the platform, and a lot of it is wrapped around one of my favorite topics, which is collaborating with the community to come through to develop effective solutions. So I'm going to talk very little about the platform because James covered a lot of the basics in his intro talk, and I know you all were here and riveted for that. So I'm not going to recover that. I will, oh, there we go. So this is my very brief slide on the platform. So just to recap, we have our optical platform, which is built on the fiber IRU primarily. That and a combination of community spectrum. Talk about that a little bit more later. On top of that, I should say we have our Sienna 6500 platform, which is running FlexGrid, which is now capable of running waves up through 1.6 terabits, soon to be 3.2 terabits per wave. It's a lot of technical stuff, but it's a lot of capacity that we can cram into a single piece of spectrum. So that's really exciting developments that are happening. Built at the next layer is our packet platform, still based on Cisco 8000s. It's disaggregated, so it has this mesh that's shown here in the diagram. And that's the architecture that was established with NGI. Now, that has continued to evolve, the services and how it's built, but the fundamental architecture of the platform still remains the same. And of course, last but not least, we have Insight Console, which Scott's going to spend quite a bit of time talking about, which provides visibility into the services on the platform more and more year over year as we add features. So that's kind of the continuity of the current Internet2 network infrastructure. Service layers, again, James showed this. I'm not going to spend a lot of time. Layer 1 through layer 3, sort of talked through that. We have the R&E service, I2PX, DDoS, Cloud Connect, RPI, all running at that level. Of course, we're part of the larger ecosystem, which is going to come up several times in the course of my content. This is the Quilt map. This is one of my favorite maps, actually. I'm kind of a map person in general. I love a good map, and I love this one because it shows the Internet2 infrastructure overlaid on the regional infrastructure, regional state network infrastructure, and it kind of just gives a vision of how complex the nature of the ecosystem is. And for any service that's being consumed for the most part, that has to follow through many networks, the Internet2 network sometimes, to be successful. So these partnerships are really the key in everything that we do. So what's collaboration in general? Collaborative infrastructure development. It's all of these entities, Internet2, regional and state networks, campuses, government, and industry all working collaboratively to co-develop solutions and solve collective problems. And so today I'm going to go through some things that we've been doing, particularly with spectrum and optical systems and optics, to solve some collective problems or some challenges that we've been working on. There's also been a lot of change over the last decade. So I came to Internet2 in 2015. We had a relatively, to use the term, closed system, and we had a relatively small number of services that were being delivered. Over the last 10 years, our systems have become more and more flexible in how they can be implemented. I think the term is open. Often open line systems or open systems gets used. And over time, there's been just a huge growth in both the flexibility of the Internet2 platform, optically through the packet services and how it can be implemented. And so these are just some examples of some of those evolutions. We're starting to see some changes in fiber availability. It tends to be in certain markets, certain areas where a lot of the fiber has been, shall we say, taken up by a lot of the cloud service providers. Sometimes we've seen IRU costs escalate. We go back and the IRU maybe is twice as much as it was previously. I mentioned kind of the open nature and the sort of proliferation of software tools and software provisioning. including Insight Console and the Insight Console API, but also at the lower levels for things like NSO and ClickSon. And I mentioned the open aspect. The other thing that's really changed is that we've started to see spectrum and partial fiber leases that are now becoming commercially available. So instead of maybe solving a connectivity problem with an IRU in my own line system, we would look instead at spectrum or a collaborative spectrum solution instead. And so we can control some costs through that approach as well. Even better if you can do it through collaboration. Of course, we're starting to see coherent optics come to market, which creates an inherent simplicity in how you're deploying bandwidth as well across these fiber and spectrum systems. And it's also the race to 800, which is definitely where the emerging transport solutions are. I'm not going to talk about maybe the next Internet2 packet infrastructure today, but I will say that it involves 800 gigabits, absolutely. So here's some of the things that we're working on at Internet2 that sort of combine this concept of spectrum and coherent optics. So the example on the left is how we're starting to turn up new backbone capacity inside Internet2. Traditionally, with the NGI platform, we used wave server modules. So you had your line system, your ROADM, your fiber, your ROADM, your wave server module, and your switches. And you kind of had all of those components, and sometimes you even had intermediate cards to, say, provide 10 gig services on top of the 100 gig waves or the 400 gig waves. And so they had this very dense stack of hardware with a lot of components that could fail or go offline during an upgrade. But the move to coherent optics really changes that dynamic. So we're taking a lot of the complexity out of the system, and we're slotting a coherent optic into the switch, and it is connecting to the ROADM directly. So you may be able to remove anywhere from 1 to 3 pieces of hardware in the chain. So this is much more efficient, maybe not spectrally efficient, but we do have an IRU, it is lit, we have full spectrum. We can afford to trade a little bit of spectrum for this flexibility and this simplicity in our deployments. And so we're pushing this technology out into all different parts of our network. So I have another diagram where I show the number of links that we have up, but we're putting this on long haul segments, kind of out to about 500 kilometers, and we're deploying a large number of these in the metro for metro capacity. So the right diagram here shows a typical metro installation using coherent optics in a mesh. So you can imagine the cloud and the CSPs are above the switches, the peering nodes, and our backbone is on the lower section. And so you gain a lot of capacity. You also gain a lot of the critical redundancy and resiliency requirements that are required by the cloud services. Again, highly efficient. So we may have gone from needing 2 racks in a location down to being able to fit into a single rack because we don't have the transponder infrastructure. Our power level loads drop. The other effect, which I don't have here, is we sometimes gain ROADM resiliency as well because we have more space in which to place that equipment. So there's a lot of drivers here. Another really cool thing that we did recently is we had a proof of concept with our partners over at Cisco where we used a coherent optic to go 3,000 kilometers. So you may think this path is a little strange operationally. What we did is when we turned this up, and I don't have a graphic, sadly, that shows that Ross Schaefer, who works in my group, did the majority of the work on this. We started on a very direct path from Indianapolis to Albany, and it worked, and we had great margins. So we came up with a slightly longer, less direct path. It still worked, good margins, and we just kept getting more creative about what segments we added, and we ended up with this, which was about 3,000 kilometers, all on a pretty clean section of network, and we were able to run 400 gigs between 2 coherents. So it's pretty striking. We used to have to use premium level transponders to get these distances at these speeds, but this is done with a single optic, which is really a cool thing when you start to think about having to deploy spot capacity for emerging demands. So if you think about this on a domestic scale, if I have a new bandwidth demand that pops up, I can just slot coherent optics, run 3,000 kilometers, and effectively put in capacity in a managed way. So just thinking about how prevalent coherent optics are, all the red lines in this diagram are coherent optics that are now operating on the Internet2 platform. These are almost all Cisco, Bright, 0 dB coherence. So they're best used on these longer distances. For some of our metros, we probably could have used something that had a little less launch power, but for consistency's sake, we standardized on these, and they work very well. So you can see in our metros, for example, in Los Angeles and Chicago, New York, we have our sort of mesh topologies set up. Dallas also has a mesh topology on coherence. One of my updates didn't quite make it in. So we've actually got 3 of our major peering metros retrofitted with coherence. And some of these are not what we call a split metro, where the cloud is at one site and the core node is at another. And so they don't need a coherent solution because we can just run client optic. So we're basically up to 25% of the capacity, or at least the optical capacity on Internet2 is now being supplied by coherence. The cool part about that is that it allows us to redeploy our wave server modules to more long distance and targeted uses, which I'll comment on in another slide. So another really interesting thing that coherence allow us to do is, again, with little hardware footprint, they actually allow us to transit other line systems. So in this case, I say community line system. It's actually a line system operated by NERIN, the Northeast Research and Education Network. And they had an application where they actually wanted Internet2 services and their own private services configured at one of their data centers. They wanted to leverage the Internet2 platform and the Insight Console software tools. And so they asked us to extend the platform into their facility. So in this use case, we have 2 Internet2 backbone nodes in different cities. It's traversing a third-party line system using coherence. And then there's a remote, effectively, and well, I wouldn't even call it off-net because it's on-net, Internet2 node off-net by the optical side that's at the Green High Performance Computing Center. So really interesting application that allows us to extend with great simplicity. In the case of the NERIN system, we've actually done even more with our coherence. Not only are we extending to the remote compute system, but we also put additional nodes across Metro and Boston as well. And then we also used coherent to pull some traffic back around between Albany and New York. So very dense application for coherent optics, both on the Internet2 line system and on the NERIN line system. The other thing that we're seeing is going city to city via spectrum on, again, a community members line system. So in this case, we are under study on the northern tier. PWNGP has long held an IRU on this fiber. And again, this is preliminary, it's under study. But we are looking at using WaveLogic 6 modules to traverse the northern tier so that, and if we went back to the national map, there's effectively 2 east-west paths that the community uses to get from the East Coast to the West Coast. For optimal resiliency and redundancy, we would like a 3rd path at our regular line speeds, currently 2x400. Ideally, in a year or 2, we're going to be talking 2x800. And so equipping a 3rd path is of incredible value. And we can do that using this concept, whether it's coherence or whether it's WaveLogic 6 modules, of crossing another line system to make key connectivity for the community. And so in this case, we're actually looking at being able to go up to 3 by 800. So 2 by 800 meets the baseline requirement probably for the next generation of the Internet2 network, but then we've got some surplus capacity as well that can be leveraged. So these modeling results are underway. This fiber topology is fairly long in length between the add drops, and the fiber types are not as optimal, but we're still seeing excellent performance predicted on this particular application. We've also had several examples of building similar systems using the Internet2 platform. So this is city to city using foreign spectrum or Internet2 transponders or pluggables, but serving one of our community members. And so I found 2 easy examples here. The WRN network is using Internet2 spectrum, but community-owned transponders that builds that entire platform. And the NAREX connects community exchange points, again, many which are not owned or operated by Internet2, across the Internet2 platform, and creates these network overlays. So it works kind of in both use case scenarios of using either the Internet2 line system with third party or a third party line system with Internet2 equipment. Another thing that, again, we're sort of combining all these different network layers. We are seeing a lot of interest in extending Internet2 into other locations. So we're not just using dark fiber to go the last mile. We're actually placing new ROADM nodes, or we are placing new optical nodes in what have traditionally not been connected sites. And this is done entirely at the request of one of our community partners. So someone says, we know you go through this region, but we not only would like you to extend, but we want to connect to you either with a dedicated switch or a dedicated router, I should say, or we are going to use foreign spectrum to traverse part of the Internet2 line system, but we need you to come to us. So we're working 5 or 6 of these right now, potential changes to the topology based on a specific community request. So combine all these different aspects of flexibility, coherent optics, and suddenly the options really multiply on what you can do with the community infrastructure. So I just compiled a short list. This is my last slide before I hand it off to Scott. These are just some of the things that we have been working on, and I won't necessarily read them all, but there are various places where there is a community collaboration. There are community foreign spectrum that we are leveraging. There are places where we are building into, some of which are still under study, and there's of course the collaboration on NAREX, which connects exchange points. And so this is not just a speculative activity. It's not something that we see coming. It's already here, and we're already actively doing it. So I guess my close on that would be, if there is an interest in a new location or an adjacent location to where Internet2 is, if there is interest in doing even a proof of concept on using spectrum, or there is an opportunity to close a gap in the Internet2 network that would lower latency, we'd love to talk about it, because we've evolved quite a bit over the last 10 years since I came to Internet2, and that flexibility that we're showing these days is really exciting to kind of embody and have everyone kind of come in and contribute to. So thank you very much. All right.
All right. That's some really cool stuff. I've been in networking for 20 plus years, and it never ceases to amaze me just how cool the technology is and how it keeps advancing. So some pretty neat stuff there. Thanks for sharing, Chris. I'm going to stand here and talk a little bit about the value proposition of these services and how you could leverage the infrastructure within your organizations. And hopefully we'll have a lot more conversations about how you can work with us in collaborative ways to push us into new services and challenge us to come up with new uses of these services. I know Chris showed this slide, and if you were here yesterday, you saw James Deaton show this slide, but in almost every presentation I've done over the last 6 months or so, I put this slide in my deck. And I think it's just a really important slide to have to show the different building blocks of the services, the different tools in your toolbox when you're thinking, when somebody comes to you and challenges you with, hey, how do I get connectivity? How can I build this service? How can I solve this challenge? These are some of the tools in your toolbox, and I think it's a really important slide. So we had, Chris mentioned NERIN, the Northeast Regional Education Network. They came to us and challenged us and said, hey guys, we're traditionally an optical platform that connects the Northeast New England states together. We want to extend some packet services and share some services between each other, but we don't want to outlay capital and build redundant infrastructure and equip same packet equipment and similar POPs that you're already in. What can we do together? And so we've worked with NERIN to develop a service that we call MDLP, Managed Dedicated Local Platform, where we place packet equipment in locations that Chris mentioned earlier, and extend a whole bunch of interfaces towards the members. So the 7 NERIN members, they each get their own physical connection to the network, and they build services, they configure services with us for I2RE, I2PX, Internet2 Cloud Connect for cloud connectivity, and layer 2 connectivity or layer 3 connectivity between each other, all without placing any of their own equipment. And it's made possible, I'm going to talk about this next, leveraging our Insight Console. So they've really got a full suite of tools at their disposal, and these are all services that we've traditionally used and leveraged, but they've challenged us to kind of combine it into one complete service that they can consume, which is pretty cool. So Insight Console, wearing one of my other hats, I spend a lot of time working with our team developing Insight Console, and I'm pretty proud of this team. They've done a real lot with this tool. In less than 2 years' time, they've brought a lot of functionality and tools into our console. Today we've got Looking Glass. Everybody can just go to console.internet2.edu, and you can get a view into the network, run a trace route, run some pings, run some commands to see what routes we're accepting from different networks. So that tool, that was our first release. Since that time, we've released communities, which allows our organizations that connect to us to go out and build child organizations for each of their members so that they can get into the console and have visibility as to how they're using services, what their cloud connectivity looks like. We've built the service interfaces to allow people to delegate. If you have a physical connection, your platform connector with Internet2, you can go in and you can grab 10 VLANs on your interface and delegate those down to your schools so that they can go in and build connectivity as they need, as they see fit with these building blocks and build into the services that we have on the network. And they do that with a combination of those interfaces and virtual networks. And virtual networks is really the ability for our members to go out and build these on-demand layer 2, layer 3 networks. These are networks that are theirs. Isolated, this is really what folks that are familiar with cloud connectivity and cloud computing, this is what the cloud is doing as well. We're doing it here, and one of the big use cases is connecting our members from their campuses directly to the cloud. And then our latest and greatest, the newest release that we have, the newest feature is our Internet2 route reports and the routing integrity work. Many of you know Steve Wallace. He's been very vocal about securing your IP resources, and prefixes. We've done a lot of talk in the past about manners and how important that is for securing your internet routes, providing your network with security so that somebody doesn't hijack your network, so that somebody isn't using your IP space and getting it blacklisted. Now, I'm going to challenge you to go to Insight Council and take a look at the route reports. Verify the work that you've done with manners. Go in here, take a look at your prefixes. You don't need to even sign into the council. You can reach the route reports without signing in, and go in there and take a look at your prefixes. This is our view of what we see. Is there an RPKI signature for your prefix? If not, there's a way to troubleshoot that and drill down and see what we're seeing. I hope you have questions. I hope you log in and see and learn something new from the route reports. When you have questions, there's a nice button down in the lower left-hand corner to schedule a meeting, and that goes directly to Steve Wallace, who's an expert on this stuff, and he just lives to talk to all of you and help you with this and guide you. So I strongly encourage you to get in there and take a look at this newest feature that is part of the council. So what's next for us with Insight Council? Well, working with a lot of our members on connectivity to the cloud, we've identified a couple gaps in features that our members want from our services. So we've kicked off a design process to build some of those features and solve some of those problems. And under that, we've identified this cloud router program. And I call it a program because it's going to be a series of projects where we're working, each project is going to be a new feature release. The first two new capabilities or features under the cloud router program are going to be routing policy. So the ability to add, and it's not every routing policy and every routing feature that you might have in a router on campus, but the first subset of that is going to be to accept and deny prefixes. So if you're peering, and this is a very common use case that we've heard from folks, they're not in one cloud anymore. They're in multiple clouds. They've got their campus connected, multiple clouds. They might want to filter some of the prefixes from one cloud to another. This feature will give them the ability to build essentially a prefix list of accepted prefixes from a peer, apply that to the peering with the cloud provider, and filter some of that from reaching the rest of the network. And so that's going to be one of the first new capabilities we have. The other piece of that, as we were working through this design, we realized, man, you really have to swivel chair and flip between windows to see what prefixes are being accepted by the cloud router. And you had to flip over and use our looking glass tool in a different tab or a different browser window. And so as part of this, we also said, well, these are well-known commands that you would need to run to view, okay, did my policy work? Did I actually drop those prefixes? What is coming into the routing table? And so as part of this new release that we're working on, you're going to have the live network inspector view, which allows you to use the same window and pull up the routing table and see how those prefix policies that you applied are actually working or not working. So you could troubleshoot without leaving that one window. So that near term, that's what's next for Insight Console. Next, I want to talk a little bit about some of the value proposition of these services with Internet2. So we've recently did a cloud connectivity cost comparison for people that are using Internet2 for cloud connectivity compared to commercial service providers. Cloud connectivity consists of primarily three main methods. The first being public internet. People will build IPsec VPNs. This is often where almost 100% of folks start with their cloud journey. Build a VPN tunnel to the cloud provider. I've got connectivity, great. Internet2 supports this, and it supports it really well. We've got over 4 terabit of connectivity in I2PX support with the 4 major cloud providers. So if you're configured well and you're using Internet2 and leveraging I2PX, these VPN IPsec tunnels that your team have built into the cloud providers are leveraging Internet2 I2PX for high capacity and resiliency to the cloud. The second model that Internet2 also helps support is the cloud exchange. So years ago, folks would build into a co-location facility where the cloud providers were. They had to buy transport, procure a router, procure colo, rack space, and manage your equipment with one of these cloud providers. Actually, that's number 3, direct connectivity. I kind of jumped ahead here. So if you're building your own colo and placing your equipment directly next to one of the cloud providers, you can go and order a cross-connect and build to those cloud providers. And there's significant cost in building your own infrastructure. I guess number 2, which I skipped over, is the cloud exchange. So there are service providers out there like Megaport and Packet Fabric, Equinix Fabric, that we have folks that have great use cases for using those providers. And you consume connectivity to that provider, and then you build for each essentially layer 2 or layer 3 type service that you build through them, and they provide that little transport piece to the cloud. So Internet2 supports that with the use of Internet2 Cloud Connect through hosted or partner type solutions. And the reason I spent probably too long talking about these 3 methodologies are they're key to our cost analysis. Understanding these 3 methods are kind of core to the analysis. In this diagram, we're really trying to show you, by being connected to Internet2, you have Internet2 peer exchange connectivity. There's no additional cost for that. So hopefully you're using I2PX. The second methodology with Internet2 Cloud Connect, Internet2 doesn't charge for connectivity, hosted or partner type connections to the cloud. And you can just go in and build in Insight Console these connections into the cloud, and up to 5 gigabit per second, at no cost. The third methodology is leveraging our I2 RPI, or Rapid Private Interconnect building block, and that's for folks that have a need for a 10 gig or 100 gig type dedicated connection to the cloud. And we do have a small fee for that you'll see next. So just a few numbers on the usage. Today, I think James might have had this slide yesterday as well. We have 655 connections of hosted or partner type to the cloud, to the 4 major cloud providers. We have 59 10 gig and 400 gig connections leveraging our Internet2 RPI building block service for dedicated type connectivity to the cloud. And our cost comparison analysis really focused on those two methodologies. It's much harder for us to define and come up with a cost analysis for I2PX. So the cost savings analysis we did was really focused on just either hosted, partner, or dedicated type connections to the cloud. This QR code takes you to the full paper that was drafted and endorsed, I guess, by our NAOA PAG. And we're very confident that these numbers are actually pretty conservative. And I'll explain just briefly why in the next slide, because there are a lot of other costs that we haven't included in these figures. So they're very conservative. At the time when we drafted this paper, there's only 634 connections leveraging hosted or partner type connections. The previous slide, we showed 655. So we've, since, and it's only been maybe a month or two, we've already seen an increase in folks leveraging these services and in getting some great value out of the network. We have many connections that are under 1 gig. We have many connections that are over 1 gig. But probably the most frequent type connection we see built to the cloud is 1 gig. So for this use case, we kind of stuck with that averaged 1 gig type connectivity. And if you multiply the savings that we were able to identify, you end up with a pretty significant number of $3.8 million per year annually that our members are realizing through leveraging Internet2 Cloud Connect over a commercial provider. And similar way, folks that are using Internet2 for dedicated type cloud connections with I2 RPI, when we run those calculations, and these numbers have increased a little bit as well, we're at $754,000 annually for a total annual number of 4.5, almost $4.6 million that folks are benefiting from these Internet2 Cloud Connect services. So this is a more complicated example. And I said we're fairly confident in those figures and those cost savings because we used a very simplified model of a single connection to the cloud. I don't know anybody that builds only a single connection with no redundancy to the cloud. So in this example, you have multiple connections and it's layer 3. In our cost savings analysis, we just stuck with a simple layer 2 single connection to the cloud for our calculations. So if we had used this model, the figures would be much higher. The cost saving analysis, in fact, only uses that one figure in the red and not all these other figures if you were using a typical layer 3 type service. By leveraging and being connected to Internet2, like Niren, Niren's actually receiving everything inside the big red box. We provide them transport from the MDLP locations right to the cloud through hosted connectivity. We provide them layer 2, layer 3 virtual routers or cloud router services. And they're a great example of, instead of building transport, a connectivity with a commercial provider, paying for the virtual cross connects with that provider, paying for a routed service with a commercial provider, they're receiving all that type of value when they build their cloud connectivity through Internet2. So that's how we can say we're very confident that we were really conservative in that cost analysis. And I put this slide up again just so we've actually continued to grow the service and have more folks using the service since that analysis has come out. This is almost 25% of that savings is almost 25% of the number that folks pay for connections to the Internet2 network. That's pretty significant value that folks are receiving from connected to Internet2. So my last slide, and we'll finish up here. It's really a call to action. We need your help determining what's next for Insight Console. Right now, we're going through UX discovery. This is going to help us identify like critical pain points or features that are maybe holding folks back from using the service, or, you know, hey, Scott, I just need this one more thing, and then this would fit perfectly my use case. We want to know what those are. So I encourage you to either scan the QR code and set up an appointment to talk with us and help share some of those insights, or visit the URL below. They both take you to the same place. But this really will, your participation here will really help us prioritize the development efforts, will help drive the roadmap where we take the console, what we work on after the cloud router features. We expect to move through this phase rather quickly, the next 2-3 months tops. So talk to your teams. How are they using the console? What do they wish was different? Encourage them to go to this URL, get a meeting with us. It doesn't have to be a long, complicated meeting or conversation, but get in there and grab some time with us to talk to us about how we can improve this for everybody. And that's it. I guess we're open to questions if anybody has any questions.
This guy's on. Hello. Hi, everybody. I'm Shannon with Internet2. So my question is, what is something exciting that you've gotten from a customer as a suggestion for the Insight Console? It sounds like something I should know the answer to, but I'm actually asking because I'm curious and don't know the answer.
I have to pick one.
You can pick more than one, but you can pick one.
No, I mean, the range of suggestions they're all over the place. But it's been a while since we've done that discovery and gotten a lot of feedback. So many of those things the team has picked up, and you know, it's like, hey, I wish there was a button here, or I wish this was a little different. And the team just grabs that stuff and is like, well, we can do that in 5 minutes. Like, let us put that in and roll the release. And but Shannon, I don't know that any one thing really stands out to me. I think right now I'm most excited about the routing policy for Cloud Router, because that one solves a problem that that's tough. Like we've had many tough conversations with folks where they're like, I really need this. It would be great if your virtual router supported this. Please get this added. So I'm most excited about that one, I think, right now.
Thanks, Scott. Any other questions for Scott or Chris? Then I'll add one more thing. So there's that QR code and URL up there. But if you want to speak with the team directly who's working on adding some of these features, I have cards up here as well. Please reach out to us. And with that, thank you, Chris and Scott.